we have our carbonyl, we have our methyl group, and we've got our lone pair of electrons. So these are going to attack the carbonyl carbon. That's then going to have 5 bonds, so we break the carbon-oxygen double bond. Okay, we end up with an O minus. We end up with our NH2 plus. Okay, and then from this point we can say, well, that's fine. We know that we can do these proton transfers. Okay, so we can show that we know that this can go to OH. This can go to NH. Yep, so we do one proton transfer. We can then do a second proton or second protonation to go OH2 plus. Now the temptation might be to go straight from here to here. I mean, that doesn't necessarily show that you understand that these things are in equilibrium, so it's much better to show that, first of all you show the proton transfer, then you show the protonation because you're adding an extra proton in there. Okay, but once we get to this point, our lone pair of electrons here can reform the carbon-nitrogen double bond and our water can leave. So what we end up with is our NH plus. So that was our centre, the structure that was in the centre of the molecule had that structure to it. Okay, and then I asked what would happen if you added sodium cyanoborohydride, and what we did this morning is we know that sodium cyanoborohydride, so if we say that NaBH3Cn is equal to H minus, okay, so we know that H minus doesn't exist by itself, but it does, this gives us a source of H minus, then we can simplify this just for the time. We can have H minus attack, we break the carbon-nitrogen bond, okay, and we end up with our NH. Okay, we can say, we can draw in, obviously we've added the hydrogen, but once we've added the hydrogen it's not important anymore, we can choose not to show it. And just remember, that's the simplification of that process. In reality, as we did before, what would happen is you would have your this, and you would take the electrons out of that boron hydrogen bond. But for the purposes here, I've just simplified to show you that is okay sometimes. Okay, so that's just to show you can start joining things together. So the first one is a standard carbonyl reaction, then you form the iminium cation, and then you can do a reaction on that, which is the same as it would have been for the carbonyl group. We have